So guys, we are going to discuss a problem removing digits, right? So we are given an integer n, and what the question states is basically I can subtract any number from it which is available in the integer, and we have to find the minimum number of steps, right? So let's try to solve this problem using dynamic programming tabulation method. So yeah, so first of all, I would like to tell you all that the answer is always possible, right? Why so? Because let's say our number is 455, right? So what I can do is I can subtract the number which at the unit place, and it would be 450, and I can subtract any non-zero digit number which is left in the integer. So let's say I subtract 5, so it would be 445, and then I can again subtract 5 which is at the units place. So as you can see, in any two steps I am able to remove 10 from the number. So basically, if the number is still 1 is 6, then 1 is 6 in 1 is 5 into 2, that can be a type of max limit, which will be our answer. But I have taken 1 is 9 to be ultra sure, although you can take 1 is 7, 1 is 8, that is no problem, right? Also also what does the state represent? So our state representation here is fairly simple. The dp of x simply represent the minimum number of steps to make x to 0, convert x to 0 given the conditions, right? So what would be our base case over here? Would be simply dp of 0 is equal to 0. Why? Because if I am at 0, I don't need to take any further steps, and if I'm at 1, I can simply, although it is not mandatory to initialize it, but I have done it, right? So let's see now what would be our transition function. So our transition function would be, let's say I am at any number, right? 2 3 5. So what I will do is I can subtract 5 from here, I can subtract 3 from here, right? So 232, and I can subtract 2 from here, so 233, right? And 1 plus the answer for these number, right? So this is our transition function. I have to take the minimum of all, right? So let's also, now this is our recursive function. Now let's travel, right? uh, since what I am doing here is that if I am at I, so if I am at I, then I can only, I am fine, I am taking the help of the values which are smaller than I, because while doing I minus choices, right? So what I can say is that I should move in this direction, because if I am at here, I am using the value this side, and it will be already calculated. So I'm just filling the choices vector, right? For example, if the number is 1 2 3 4, then I my choices would have 1 comma 2 comma 3 comma 4, and then I am iterating over the choices. And if I minus choices of j is greater than equal to 0, right? So I'm going to, it is a valid step, right? So I will just simply do it. One will be I am accounting for that choices of j, which choice which I have taken, and finding the minimum for this which is already calculated. And at the end we will just simply print the dp of n, which is our final answer, right? Talking about the time complexity, the time complexity here is O of n into the length of the length of the, like, number, which would be n into 6 or something like that, but you can take an average case of 3 or 4, right? Also I am doing it too. So n into so basically it would be like n into 2 into length, right? So I'm taking it to be 3 4, right, on an average case, but still you can say it n into length complexity. If I talk about the space complexity, it would be O of n, and there would be no uh, recursive stack space complexity, right? So yeah, let's try to submit the problem. So yeah, yes guys, our solution is accepted.